Good day, grade 5. Welcome back to our science class. For today's video, we are going to continue discussing about resultant force. Last Monday, you have learned that force is the push or pull acting on an object, and it has both magnitude and direction. You also learned that we use force in our day-to-day life like walking, opening and closing the door, pushing or pumping a plastic pump soap or shampoo bottle, sweeping the floor, opening a drawer, riding a bicycle, and many more. Now, let's talk about resultant force. Resultant force is the sum of all forces acting on an object. To get the resultant force, we need to know the magnitudes or the sizes and directions of all the forces acting on an object. Resultant forces are very useful in our everyday lives. Here are some examples of resultant forces in actions. Using horses to pull a wagon will make it move easier and go faster. Another example is when many people row a boat in the same direction, the boat goes faster than when rowed by one person. Another example is riding a tandem bike. So we have here two people riding a tandem bike. They share the force needed to paddle the bicycle and make it move faster. Another example is using two chains to hold the swing helps to balance it better. Now, let's have a quick review of what we have discussed last time. We said that we use an arrow to show the magnitude and direction of a force. The length of the arrow shows the magnitude or size of a force. If an arrow is long, the magnitude or force is big. If an arrow is short, the magnitude of force is small. Let's say this arrow is an 80 Newton force. The magnitude is 80 Newton and the direction is to the right since the arrow's head points to the right. So we say this force has a magnitude of 80 Newton acting to the right. Let's proceed. We use a spring scale to measure the magnitude of force acting on an object. So this is a picture of a spring scale. We do this by fixing the top end to a stand and clamp set and hanging an object to a bottom end. Then, we read the magnitude of force from the mark on the scale. There are three cases in solving the resultant force. Let's start with case 1. If two forces acting on the same object in the same direction, the resultant force is more than 0, and the object moves in the same direction as the forces. Let's have an example. We have a bulldozer and a wood log. Let's refer to the wood log as the object. The bulldozer moves the object to the right with a 20 Newton force. The first move will be the first force. Now, the bulldozer moves the object again to the right at a 30 Newton force, which will be the second force. How do we find the resultant force? What we're gonna do is to add the two forces together, so we will use an addition. Let's say force 1 plus force 2 is equal to the resultant force. So, force 1 is 20 Newton and force 2 is 30 Newton. If we add 20 Newton and 30 Newton together, we will get 50 Newton. 50 Newton now is our resultant force. So let's say the object is moved to the right by a resultant force of 50 Newton. That is for case 1. Now for case 2, if two forces of different sizes acting on the same object in the opposite directions, the resultant force is more than 0, and the object moves in the same direction as the bigger forces. Let's have an example. For case 2, we have two bulldozers which have different sizes and again an object. The big bulldozer moves the object to the right with a 50 Newton force, and the small bulldozer moves the object to the left with a 20 Newton force. How do we get the resultant force? What we're gonna do is to subtract the smaller force to the larger force to get the resultant force. For case 2, the direction of the resultant force will be based from the direction of the larger force. So force 1 is 50 Newton and force 2 is 20 Newton. 50 minus 20 is equal to 30 Newton. So 30 Newton now is our resultant force. Let's say the object is moved to the right by a resultant force of 30 Newton. That is for case 2. Now for the last case, case 3, if two forces of the same size acting on the same object in the opposite directions, the resultant force is equal to 0 and the object will not move. For example, again, we have two bulldozers with the same size and one object. The first bulldozer moves the object to the right with a 40 Newton force. The second bulldozer also moves the object to the left with a 40 Newton force. So as you can see, they have the same size, same exerted force on the same object, but in opposite direction. So how do we get the resultant force? Again, we have to subtract force 1 to force 2 to get the resultant force. Force 1 is 40 Newton and force 2 is 40 Newton. 40 Newton minus 40 Newton is equal to 0 Newton. So our resultant force is 0 Newton. The resultant force is equal to 0 and the object will not move. Let me summarize the three cases. When two forces act in the same direction, we add the forces together. When two forces act in opposite directions, we subtract the smaller force to the larger force and follow the direction of the larger force. When two equal forces act in opposite directions, we subtract the forces. That is all about the resultant force. Now for your activity, I want you to open your book to page 82. If you're ready, let's start. How are forces acting on the objects? Take the correct statement. For number 1, the kids are playing tug of war. The kids are pulling the rope to the left and right. So, what is the direction of the forces that they have exerted? Is it in the same direction or opposite directions? That's right, it's opposite directions. For number 2, the kids are pushing a wheelbarrow going to the right. So, what is the direction of the force that they have exerted? Is it same direction or opposite directions? If your answer is same direction, you're correct. For number 3, two horses are pulling a cart going to the left. So, what is the direction of the force that they have exerted? Is it on the same direction or opposite direction? That's correct. It's the same direction. And for the last number, the kids are moving a cupboard to the right. So, what is the direction of the force that they have exerted? If you said on the same direction, that's correct. Now let's move on. This is on page 90. Find the resultant forces and the directions of the objects. For number 1, we can see two forces moving the object to the right. The forces have both magnitude of 5 Newton. So, what is the resultant force? This will fall under case 1, saying if two forces act in the same direction, we add the forces together. So, 5 Newton plus 5 Newton is equal to 10 Newton. Okay? Now, the object moves to blank. Is it to the left or to the right? Good job, it's to the right. For number 2, we have 5 Newton force going to the right and 7 Newton force going to the left. What case is this? It will fall under case 2, right? So we have to subtract the smaller force to the bigger force. 7 minus 5 is equal to 2 Newton. The object moves to the blank. What is the direction? So we can see here that the direction of the bigger or the larger force is going to the left. So the direction is to the left. For number 3, we can see two forces acting on opposite directions. So this will be case 3. So what is the resultant force? 6 minus 6 is equal to 0 Newton. Since our resultant force is 0 Newton, the object will not move. For number 4, we can see 8 Newton force going to the right and 2 Newton force going to the left. So what is the resultant force? We should subtract 8 Newton and 2 Newton. So the answer is 6 Newton. That's right. Now, the object moves where? Is it to the left or to the right? Look at the bigger force. Definitely, it's to the right. Okay, so here, read and answer the questions. Bob weighed 2 rocks with a spring scale. First, he weighed 1 rock at a time. Second, he weighed the 2 rocks at the same time. Then he wrote down this information. For the first time, rock 1 weighed 1.3 Newton. Rock 2 weighed 1.5 Newton with a total of 2.8 Newton. And for the second time, 2 rocks together weighed 2.8 Newton. So, first question, what did he get for both times? What did he get for both times? As you can see, the answer from the second time is equal to the sum of the answers of the 2 rocks weighed separately. So, he got the same answer for both times. For number 2, what can Bob conclude about the experiment? This has something to do with case 1. Case 1, when two forces are in the same direction, they add up to give one resultant force. So that's the end of our activity. And for your homework, that's on page 91, draw a mind map, a diagram, or summarize what you have learned. If you're done answering your activities and homework, take a photo and send it to the line group. Thank you so much for listening. Have a great day and goodbye.